tell us what was it that we did? Right, this is the third part, gentlemen. Third part of this exercise, correct? The first part, we just did the topology, the connectivity. The second part, we assigned the IP addresses to the interfaces, including the host computers, the workstations, IP addresses. And I think we finished the last class when we did a ping from PC1 to PC2, and we found that the ping was successful. Whereas a ping from PC1, let's say, to PC3 or PC4 was not successful. And we said the reason for that, because PC1 and PC2, even though they are on different networks, both of these networks are directly connected to the same router, being R1. Similarly, PC3 and PC4, both of them are part of networks which are directly connected to R2. So what I want you now is just a refresher before we continue. I want Mohammed Rashid, just please to confirm what we just said. And I would like you to perform a connectivity test between PC1 and PC2, just to make sure that we have a successful connectivity. Okay. What's the IP address? You can move the box a bit to the right. Yeah. There you go. 192.0.10. .10. No, this is a ping. No subnet mask. Because this is the IP address of the PC. The network address is .0. That's the network address. You should never ping a network address. You don't assign a network address to a host. Yeah. Two addresses from any network, we don't assign them to a host. One of them is the network address. What's the other one? In every network, in every subnet, there are two addresses which are special addresses, and we do not assign them to. No, which two IP addresses cannot be assigned to end user devices or host? Broadcast and network. This is why when we calculate the number of available hosts, we do a -2. Yeah, correct. Well done. Do you know why the first one was lost? Because it doesn't know the MAC address. Because in order to send a ping packet, an ICMP ping packet, it requires to create a frame. The frame encapsulates a packet. The packet is ready. Source and destination IP address, we know it. But the source, excuse me, the source MAC address is mine. The destination is destination MAC address of which one? Of the second one. But the second PC is not on our local network. It's on a different network. So what is the MAC address we need to put in? Remember what we said last time? So we need to send this to our default gateway. The default gateway being the router interface, our router interface. So we're going to send an ARP. An ARP message is going to be sent to the router, R1, asking it for its MAC address. When we receive the MAC address, then the frame we are creating will include the destination MAC address being that of the router interface MAC address. Okay? This operation of sending an ARP, and by the time we send the ARP, by the time the reply comes back from the router telling us this is my MAC address, there is a timeout, because the ICMP message expects a certain delay in receiving the response. When this delay is exceeded, there is a timeout built into the ping mechanism. Says, I did not receive it within so many 100 milliseconds, 200-300 milliseconds. The reply did not come back. So I assume something is wrong, so it will time out. During this time, by the time it sends the second ping, second echo message, already the MAC address has come, the frame is ready. So now the ping is successful. So we get a proper reply now.
So if you send the ping now, it will be 100%.
Exactly. Just press the arrow key, up arrow key on your laptop, up arrow key. Yeah, up arrow. سهم. لا 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 up arrow على الكيبورد. لا لا. Yeah, that's it. So you don't have to type it again. Okay, press enter. See immediately. Why? Because the MAC address has been cached. We receive the MAC address. When we receive the MAC address, Now we pair the MAC address with the IP address of our default gateway, and they are saved in an area of memory called the cache memory, especially called the ARP cache. The ARP cache. So if you do, for example, I'm going to type,
I have a question.
if I say ARP, so minus A, see what is done, what is showing me? It's saying 192.168.1.1, which is what the IP address of the router.
Yeah.
And the MAC address, this is the MAC address of the router. Can you see this? This is already cached.
Yeah.
All right.
So this ARP command solely for the gateway. Yeah. So it doesn't show us
The ARP, we can send it to obtain the MAC address of any host. In this particular case, we PC1 send an ARP, which is a broadcast message, to all of its local area network. So if there was 10 other PCs connected to switch S1, they will all hear this broadcast message, this request ARP message, including the router interface GI00. Okay, so GI00 here will also hear this broadcast message. They will all ignore it except GI00. Why? Because the ARP message will include in it the IP address. We are saying we want the MAC address for 192.168.1.1. So who will reply? Only that particular host with that particular IP address will reply. And why is, if you look at the PC config, this is why. Because our default gateway is here. So it says, I need to find the MAC address for my default gateway. Now it's going to save it there for, let's say, 5 minutes. If we don't ping for the next 5 minutes, it will remove this from the cache. The next time we ping again, after 10 minutes, half an hour, there will also be one timeout. The first one will time out, and then after that. Right. Now,
So
what
I
I,
have another question.
sure.
When you can reopen the config, where no,
PC?
for the PC, where you did the thing.
Yeah.
Command prompt.
Yeah.
Here it says maximum and minimum and average 9 ms. What does ms mean?
Milliseconds.
Millisecond.
Yeah. So minimum 0 millisecond. Then it cannot go anything. I mean, the minimum value, if you look at the replies, 1, 2, 3, 4 replies here, you cannot go less than 0 millisecond. Means it was like almost instantaneous.
Yeah.
It happens so quickly that it is less than 0 millisecond. So it could be a fracture of a millisecond. Yeah, so it was rounded off down to 0 millisecond. It could be, let's say, 200 microsecond it took. But 200 microsecond will be rounded to milliseconds because this kind of command will only show the time in milliseconds. Whereas the first one, it took a bit longer, 9 milliseconds. So the maximum was 9. At the least was 0. And the average, it averaged it divided by 4 because 9 divided by 4 is 2 point something. So it is rounded to 2. This is where the average came. Okay, good question. Right, so what I would like to do now, okay, let me ask Mansoor. Can you please now do a ping from PC3 to PC4? Before you do it, Mansoor, what is the network address for PC4? What is the network address? PC4.
172.16.0.
Network address. Network address. What is the network address for PC4? Have a look at the diagram. Yeah. What is it? 192.168. Just don't type it. Just tell me, what is it? 172.0.0. What is the subnet mask for this network, Mansoor? Well done. Okay. What is the host address for host address? See, what I ask you first, what is the network address? Now, what is the host address for PC4? .0 dot? .0 dot? Have a look at the diagram. What is written on PC4 inside the screen? 10. So it is 172.16.10. Well done. Okay.
network address 172.16.0.0 صح؟
Exactly.
والهوست اللي هو اللي على PC4 16.0.10.
Yeah, this is one of the available IP addresses, host IP addresses in the whole range. The range is from 172.16.0.1 all the way, excuse me, to 172.16.255.254. Why 254? Because 255 will be the broadcast address for this network. See, same thing happened again. The first one was lost, timed out, the first echo message. And then do it again, please. Arrow, up arrow key.
ليش يطلع أول شيء دوس عقب يطلع؟
Okay, who wants to explain this? Who wants to explain this? Rashid, do you want to explain this to Abdullah? Why the first one was timed out and then after that?
The first one timed out because the first time the computer is asking for the IP. So it sends a message ARP to the router, and then the router says that the IP is on PC3. After that, it might get lost because there's an amount of time that it's possible for it to reach, and the time has run out. So it says that it's lost. But after that, because it gets the IP,
Gets the MAC address. Gets the MAC address.
And then it will be stored in the cache for about 5 minutes, depending on how much you have the timer limit. And then if you don't ping it, it will redo it again. So you will have one DOS, and then you have the others that come back again.
Thank you very much, Rashid. Well done. Okay. Right. So now I'm going to give control to. Before I do that, let's check also the ARP -A. Notice now the ARP cache has 170.17.0.1. Why now it's a different IP address? What's this IP address 170.17 for default gateway for which PC? PC3 or PC4?
Both of them.
No, PC4. 4, because we could PC4.
3 and 4.
No,
Sir.
no, 3.
3, my own default gateway. Now, this is PC3. PC3 was pinging for, this is the one was starting the ping process. So if I look at PC3's configuration, notice the IP address, the default gateway is 17.0.1. Okay, so I'm resolving the IP to MAC address for my own default gateway. Okay, PC4. Okay, now, right,
I
yes.
have a question. It's telling me that IP address كان مثلا 172.168.32.32. الديفولت gateway آخر شيء يكون 33.
لا, default gateway, you decide what's the default gateway. I could have put in here for PC1, for example, the default gateway, I put it 192.168.1.1. It could have been any IP address, unused IP address in the range of valid host addresses. Now, this network is 192.168.1.0. That's the network address. The host range is from .1 up to .254. .0 I cannot use as a network address. .255 I cannot use as a broadcast address. So the range from .1 up to 254. It's up to me. You decide how you plan your IP addressing. For me, I put the first available IP address. I gave it to my default gateway interface, the router interface. I could have given it .2, .5, .10, .15, .254, as long as I don't give the same IP address to 2 machines. Okay? So this is the main thing. It has to be in that range. In that range.
What's the local link address?
Local link address where are you looking at?
No, in the IP
Local link address. This is okay. You did IP version 6?
No.
Last semester. Okay. Link local address. This is basically the IP version 6 address for a PC which is only valid on that particular segment. It's similar to a private IP address that is generated by the machine itself. You know, if you have a machine which is set to obtain IP addresses automatically from DHCP. But there is no DHCP server. It comes up, it will assign itself an IP address from the range 169.254.anything.anything. Automatically, it will give itself. Have you noticed this? When you're not connected to the internet, you have an IP. This is an IP version 4. The equivalent of it in IP version 6 is link local. Why is it link local? On this particular link, the link between you and the router interface. So it's like a local LAN. So this IP address is not allowed to even go across to another network on the same router. It stays here, only here. This is why we call it link local. And this link local always starts with FE80. FE80. Whenever you see FE80, you know this is a link local. And it is auto-generated by the system. You can manually, I can now go manually and change it myself. I can, for example, make it to a 1. Very simple one. FE80, colon, 1. Mean FE80 and then all 0, 0, 0s, only the last bit is a 1. See it? This is me, I change it myself manually. But normally the machine will automatically generate this. Where does it get all of those strange numbers? Let me just close this and open it again. Oops, okay. Let's try another PC because it's already saved it. Let's try this one. Where did it get this from? Where did it get 2024AF-FE? Where did it get all of this from? Okay, can I show you a bit of magic here? If I go here and say ipconfig/all, can you see the, this is the link local address.
Yeah.
That's the same one we saw there, link local address. This is IP version 6. Yeah. Can you see anywhere else in this output some similar numbers?
Yes.
Exactly, the MAC address. The MAC address. It is actually the same MAC address is used to generate the link local address. Half of it, this FE80, this FE80, this is your network address, what we call the network, also known as the prefix. Network prefix. In IP version 6, we don't call it network, we call it prefix. Otherwise, it's really the network address, just the word. The rest of it, all of this, we used to call them host. In IP version 4, we call it network and host. In IP version 6, we call them prefix and interface. So the word interface in IP version 6 is exactly the same as the word host in IP version 4. Notice this host or this interface address is the same as the MAC address with one exception. In the middle, we have inserted FFFE. Has been inserted in the middle of the MAC address. Between the 4A, between the 4A and the B1, right bang in the middle of this MAC address, we inserted FFFE. Okay, so anyway, this is beside the point. It's a bit of a digression, but anyway, you've asked of it, so I thought I'll answer you. So this is what the link local address. Right now, I'll give it across now to Khalid. Khalid, can you please now ping PC1 to PC3? Just one click. One click. What's the network address, Khalid, for PC3? What's now, what are you pinging here? No, PC3's IP address is
10, not 1.
what's the IP address, the host for PC3? It's 10, yeah? Up arrow, and add a 0. What is the message? destination host unreachable. You need to understand the different kind of messages. We didn't get timeout now. Timeout, meaning there was a path. The router knew what to do with your packet. It knows how to find the best path to destination. But there was some kind of delay. There was a delay caused the timeout. Normally a timeout will happen if there is misconfiguration or because if you're doing an ARP. However, destination unreachable, the router says, I don't even know what to do with your packet. There is no path. Sorry, it's not, I don't even know. It's not like it doesn't know. It knows exactly it has no path. Yeah? It's not like it's confused. It has a path, but it's not working. No, it says, I know for a fact, I don't have a path. I cannot take you there. So the message itself, the ICMP, the Internet Control Messaging Protocol, ICMP message, gives you a clue to the source of the problem. So when you are troubleshooting, when you look at this problem, you say,
I know the way, but I can't take it.
no, it says, I don't even know the way. I don't know the way. I don't have a way. So immediately you start thinking, oh, let me check the routing table. So close this, please, Khalid. Now I want you to open R1 and do, what do you do? Okay, first of all, let him log in. Give him time to log in. Class, good. Now, first of all, First of all, tell me, can you please confirm to me using what command you're going to use to confirm to me what IP addresses have been assigned to interfaces? Show me which interfaces have been configured with a valid IP address. What is the command? Anybody can help?
Show IP address interface.
No IP address. Show IP interface brief. Hold on. Show IP interface brief. You don't need to put the word do if you're doing it from the privileged exec mode with the hash. From any other sub-configuration mode, you need to put the word do. Otherwise, the show will not work. Because we're not using it. Are we using it?
No.
We're only using, let's have a look. So we only have on R1, we have GI00, GI01, and S00. These are the three. And it's telling us everything is fine. They're all up. They're all up, working. So why the ping did not work? So what is the next troubleshooting command you will use? I'm just trying to give you sort of the steps. The first thing you do, let me check my router interfaces. Perhaps I forgot one of them shut down. I didn't do no shutdown. So they're administratively shut down. This will also cause the destination unreachable. This is the easiest one to check. No, the answer is now negative. Everything is fine here. So I need to now go to another step of troubleshooting. What is the next command? Anybody who can? Abdullah, anybody? Mansoor? What is the next command I could try? Can you help Khalid? What's the next command I could try to see why the router does not have a path? Show what? It's all show commands, mostly show commands. Not running config. We can do running config, but something that will immediately tell us why this router doesn't have a root. Show IP root to show us the routing table. Okay, Khalid, the next time you want to leave the help, just press Control-C. Control-C instead of keep pressing space bar or, okay, Control-C. Enter. Right. Let me just quickly, so that you don't waste your time looking at the entries with an L next to it, just quickly explain what the L is. The L, this has been added for new routers, such as the 2900 routers we're using here, when they're running the latest operating system version 15, iOS 15. This is relates to telling you that this interface This particular interface has this IP address. So the L, if you notice at the L here, this is the local IP address, 10.100.1.1. Which one? This is my serial 00 interface, has this IP address. Notice the subnet mask is 32. 32 meaning the whole IP address has been masked. The whole 32-bit has been masked. Whenever you see an IP address with a /32, this IP address is a host, not a network. It's a single host, not a network. Whereas the actual network, look at this. The actual network is 10.100.1.0 with a /30, which is what we have here. Can you see?
Yeah.
This is our one interface network address. So now we are concentrating on the network addresses. So ignore the else. How many C's do you have?
3.
What are they?
All directly connected.
All directly connected. Now you did a ping from PC1 to PC3, and PC3's network address was 172.17.0.0. Do we have it here listed?
Because sir, we did not connect the two routers together.
We connected them. They've been connected. There's a cable connected them. But where is the IP address? Where is the network address? It doesn't. There isn't one, is there? Now we can see why PC1 cannot reach PC3. Because when PC1 tells its own router R1, can you please take me to PC3? R1 is going to say, let me check my routing table. 10.100, 10.100, oh, there is no 172.17. I have no idea. Destination unreachable. The reply will come back to you, destination unreachable. I don't have it, says I don't have it, okay?
So how can we add?
Okay, and this is what the topic is of this whole semester, routing protocols. And I mentioned briefly last time about static and dynamic routing. And I said, I went one step ahead, I jumped to chapter 3, and I gave you an introduction about static and dynamic routing for this purpose. And I said, this class will do static routing. We'll do static routing, make sure everything is working. Then we're going to build on this example. Then we put in what? Dynamic routing. Okay. Anybody remembers the command I gave you last time for creating a static route? Do you remember the command I gave you? Anybody remembers it? No, no cheating. I want you to remember. What was the command I wrote on the board? I said, this is the command you use to create a normal static route or a default route. Okay. First of all, I need to go to global config to do this. No, there is no show. Show only for showing. I want to configure something. Now I'm in global configuration. I want to create a static route. It starts with IP. Anybody remembers? What comes after IP? IP? What am I trying to create? What? Create what? Route. So IP? Route. What am I trying to reach? Which network I'm trying to reach? Okay, what is the network address for PC3? 172.17.0.0. The network address. Be careful, network address. What is the subnet mask for this network? Yeah? Okay, now for me to reach this network, imagine yourself, you are a packet. You're a packet on your journey. You are leaving PC1 and you're traveling. You're traveling, like, let's see, let me bring some interesting, arrow. You're leaving PC1, you're traveling along here. You're traveling, you're traveling, you're traveling, you're traveling, you're traveling. You got where? You got to R1. Now we are creating the static route on R1. Now R1 says, in order to reach this network, where do you think it should pass my packets out of? This interface or this interface? The serial. The serial. Okay. Now let's go back here. I haven't put in the where is it? I haven't put in the serial interface. So this This is serial 0, 0, 0, correct? And what is it here? This is also serial 0, 0.
Yep.
This is also 0, 0, 0. Okay. So this is serial 0, 0, 0. Okay. So it needs to take it out of serial 0, 0, 0, correct? Let's try it now. So I'm going to put serial 0, 0, 0. Just show it here. Okay. So saying I'm going to route in order to reach this network. I'm going to route you out of my or switch these packets out of my as 0, 0, 0.
So this is for the R1, not the R2.
This is R1. I'm on R1. Okay. Enter. Now let's try the ping again. Do you think it will work?
Yes. Because we have opened the path.
Let's see.
I don't think so because
Let's see. Are we going to get a similar message or a different message?
different message.
Ah,
Because sir, you don't configure router 2 to reply.
well done. Well done, Rashid. Well done.
Router 2 doesn't know
Because now R1 knows what to do. This is why I didn't say destination unreachable. It says, yeah, I know, I can take it there. And it took the packet to R2. But it's waiting for R2 to reply, but R2 did not reply. This is why there's a timeout now. See the different type of SICMP message, error message is getting? They give you always a clue. So now I need to go to R2,
R2.
IP.
enable, and class, correct? Okay, now I want you, okay, I want you, who shall do it? Abdullah. Abdullah, I want you now to configure R2 so that it can reach PC1's network. And then we'll have a break after that.
Come see.
لا أول شيء كان كل وين صار؟
PC أي R2
R1.
Sharman.
No, R2.
R2. يلا
Good.
لا أكيد 168.
Mm-hmm. Hold it, just 1 second. Where is PC1?
okay. 0.1.
Why you didn't put 0.10? You put 0.0? Because we need to put the network address. The network, not the host address, network address. Okay. Then we need to follow the network address with the subnet mask. Okay, now this is the network I'm trying to reach. In your opinion, what is the exit interface R2 needs to send the packets out of or switch the packets out of? Which exit interface?
0/0/0.
Well done. Doesn't matter.
So we don't do no shutdown.
The interfaces are already no shutdown. The interfaces. Now we're creating a route. Now go back to PC1. Go to PC1 and do the ping from PC1. That's okay. PC1. You're clicking on the names. No. No, you click on the PC itself. Okay, right. Okay. Command prompt. Now do the ping again. You can use the up arrow, it's already there. Okay. No, you're pinging yourself. You want to ping PC3. There. That's the one. Someone else's. Okay. Just click on the desktop, back on the desktop. Okay, press enter. There you go. Now it's working. Do you see that? Okay. Now we've done it for one network. How many networks we have? Okay, we have one more. The PC4 network we have, and then PC4 we need also to do back to this. Okay, so so
Even PC2
right?
is that. PC2 is that.
Exactly. Yeah, we'll do the rest of them after the break.
So I got only from router because it has the path for everything.
Yeah.
خلاص انا عندي تقريبا المفروض على
Close the recording, sir. Otherwise, it will be bad. Bye.